So my presentation is intended to show my experience using NuttX. And again, thank you very much for, it's an honor for me join you guys, expert guys, about this future of the NuttX that I will explain. It's about a future that the equipment that I develop, the data logger, has to be ultra low power data logger. It's because data logger runs with an internal battery and has no other source of energy. Okay, and in this project I use the STM32L4 family. Okay, in this project I have some requirements for using the product. Uh, they must run in low power mode, and the main task of the data logger is the read sensors. Usually, each 1 hour is 1 hour read sensor. In this interval is fine for the application that I set the data logger. Okay, you can, of course, change the measure time in 1 hour, 2 hours, 10 minutes, but 1 hour is the default mode. Okay. It must run with a lithium polymetal battery, 3.6 voltage. We use a 13 ampere hour battery from Safit. It's a French company. It's a battery for very good quality. And the current on standby must be less than 50 microampere. Okay, it's this. Of course, the data logger has many more requirements, but for the subject that I will talk, this is the most important. About the board, okay, we don't for this project we don't start using the full board or a board from market. My company is specialized in hardware design, and my partner, Mr. Gabriel Panasco, developed a board using this microprocessor. Okay, so the board is a custom board made for my company. And some features about this microcontroller that we choose is a Cortex M4 MCU that's run 18 megahertz with 55,012 kilobytes flash memory. Okay, and all the peripherals, all the circuits that is stand in the main board has to be low power too. So we choose the power regulator, the peripherals, all the components has the same feature, like I said, to be low power. Here a picture from part of the schematic of the data logger. You see that it has 100 pins, and all the pins is used. Okay, so in the start of the project, we start not using too much pins of the microcontroller, so the project evolve, and you can see that there's not much room for another feature or another component that we can connect it to the microcontroller. Okay, the microcontrollers runs on a crystal from 50 ppm, 12 megahertz, and RTC2. Okay, 32768 kilohertz. Some informations about this microprocessor. On standby, we set the microcontroller to run in stop mode 2. In this stop mode 2, we have the full retention of the RAM memory and runs, it consumes only 1.1 microampere or 1.5 microampere. In my case, it's 1.5 microampere. So this current is very low, and requirement of my board is 15 microampere. So the microcontroller is not the main cause, like I can say, that the consumption of the board is the other peripherals that will consume more current in this project. So you have to configure very well the pins to the another peripherals, another parts of the board, like I will say before. The RTC can be activated in this mode, the stop mode too. In RTC, in my case, wake up the board too. The version of the NuttX that I use is 10.0.1. It's a pretty old version of NuttX. This project starts in 12.12. Okay, it's the start of the COVID problem, and this moment I was not programming in my company. I was working in another area, and because the COVID, I could spend my time and my experience implementing NuttX in this board. Okay, Alan helped me a lot in the start, and pretty in the last. Always when I have some problem, Alan helped me a lot. So Alan is a great guy that always helped me. And I started the project by cloning the STM32L4 76 in the keyboard. So it's a good thing to do when you start a project is find some board that has the same microcontroller that you use on your board, or similar microcontroller. So you can start from there. Is very recommended do this way. And I implement a custom driver to handle the pins configuration. So I create a new driver, many others, but for this subject, the STM32 pin control. And this driver, like I will say in this part, this driver will handle all the configuration that I need on the peripheral that my board has, okay? So you can see the structure of the code. I had a lot of function that changed the pin configuration to manage some driver or manage some components that I need to establish communication, okay? And for using the power mode to enter in standby, I have to configure this driver on the PM callback structure. So I implement two functions in this driver called PM notify and PM prepare. What's the hardest part to, in my opinion, to a low power project is to configure all the pins of your microcontroller properly. If you mistake one pin, pulling a pull-up resistor in cause your input pin, and this pin is not properly configured, it's not pull-up that you need to configure, you have a consumption of these pins that is not that you want. So each pin you must specifically, if you use an input pin, you must configure to float, pull up, or pull down. And in case of output, you have 4 options. Guys, are you hear me?
Yes, everything is fine.
Okay. And if you select the pin as output, you have 4 kinds of configuration. If the output is open drain or push-pull, the open drain, you have only the MOSFET that set the pin to G and D, and the push-pull, you have 2 MOSFETs. And if you set this pin to be 1 or 0, set or clear mode. So you have to do all this configuration on all the pins that you have. This is mandatory on this kind of project to set the lowest current possible. Here an example on my driver. I defined some specific configuration for each pin. With LP, means that the configuration of this pin is to set to low power. And as you see here, just a part of my code, I have to, when I enter in the standby mode, I reconfigure all the GPIO pins to low power mode. NuttX has many.
Oliver, I think
Sorry.
we have a small issue here. I don't know. Ali is okay in your side?
Yes, I could hear the presentation okay.
Okay, I think we disconnected here for just a second. Uh, okay, Oliver, please just restart this last page. Yeah. Okay.
Okay.
Yeah, I think only this page is okay. Thank you.
Okay. Well, perfect. And the last page, I said that that pin that you have on your microcontroller, you have to configure to low power or the normal mode, not low power. So when you enter in the standby mode, I will present you in the next page. You must configure all the GPIO pins to low power mode that you have in your board. NuttX has many modes to configure power management. In my case, I select the grid power management modes. On the grid, it lets the application directly control states via relax and state calls board control. What this means? My Datalogger has to read all the sensors, record this data on the memory, and transmit this information immediately. After that, he must enter in standby mode and waiting another hour to start again and over again. So in my application, the applications know when enter in standby. So when all the things is done, my applications set the relax on the modes of the board has. It's idle mode, standby, and normal. And in my idle function, I check if the modes changes, and if changes, I call so the function change state. On function change states, the power management check which driver has to be called to prepare the system to enter in standby, and after that, notify the driver to enter in low power mode. In my case, I had only two drivers that enter, notify, and prepare. The ADC, the serials. For instance, in the serials, the prepare functions clean out the buffer instance, clean out the interrupt, so the notify finally disable the serial completely. Okay, and what will cause the system to wake up? The RTC will wake up my board. I have a button to debug function and test. So if the user press the button, the system will wake up too. And I have a USB cable that if you connect the USB cable in my board, the board will wake up too. I have only 2 minutes. I think I need to speed up a little bit. So after enters the low power mode, I has is 55.8 microampere on my board. So it's current less than 50. That is the main requirement of the board. So I did it. I could enter in low power mode using NuttX. That's the main challenge. Conclusion about the NuttX that I started using NuttX in 2020, so I used it for 3 years. The product that I made is in production. I sell more than 600 Datalogger on these last 3 years. Is a wonderful product. The main product that my company sell today is the Datalogger, and I say that is very stable and robust. There are devices with more than 2 years of uptime. In fact, 2 or 3 years, the Datalogger don't have to reset for any reason. So we have to read the sensor, enter standby, and repeat over and over again. Okay. with NuttX, in my opinion, it's easy to create new features. My Datalogger has some first features and will increase in the future. I have now transmit information using LoRa, using Wi-Fi, and now I will implement another model, LoRa module in my Datalogger. And it's very easy if you start using NuttX and using modules, not use so many mess on your code. If you organize it from start, it's easy to create new features. And then, of course, there is a learning curve, but once you master the OS, projects evolve very quickly. I start coding NuttX on March in 2020. On August, I has my first selling of Datalogger. So it's a very, very short period of time, less 6 months. And of course, the first product that I sell has some bugs that I can manage with my customer to handle it. And now the product is very stable, and my company, like I said, is the main product that I sell on my company. Special thanks, of course, to Alan Assis. Alan, thank you very much. I never will be tired to say that you saved my life, man. You present me NuttX. You helped me a lot on the project. On the application part, I have some doubts about the strategy on my application. Alan helped me a lot. Mr. Thiago Manzak, a big friend of mine, work on Finion Technologies. And my partner, Gabriel Panasco, is a hardware design. He made the hardware design, and he is my partner on Auro Technology. Thank you very much, guys, for your time, your patience. So we can start now some questions. I think my time is done.
Yeah, it's okay. Thank you very much, Oliver. I'm glad to help you. You don't need to say thank you.
No, I need to. Thank you very much.
Actually, your English is very good. Don't worry about it, and you just need to don't be so humble. And I think you are able, for example, to present in international conference, not only here in Brazil, but in Europe, United States, or any other place.
Thank you.
So guys, let's see if we have some questions. Anyone has questions about the NuttX for low power or for the project that Oliver did? Someone in the audience? I think we have one here. Let's see if it's related to your project. Yeah, it is more general, but is there some way to systematically configure the pins while paying attention on those needed for JTAG or SWD, etc.? If Oliver, if you want to discuss, I think we don't have any issues to share the SWD pins, right? You didn't use...
No. Let's go. Here. Yeah,
you use the default SWD pins, right?
Yeah. SWD pin. Okay. This is not shown on this screen, but I use in the default.
Yeah. Normally the issue is when you are using JTAG, and then you have many pins, 5 or more pins, so it could be an issue. But I think in this case, it's okay, because SWD use only 2 pins, and normally they are not shared. So I think we don't have any other questions here. Thank you very much.